Okay, welcome back to my basement. As you have undoubtedly heard, uh, the governor has put us in lockdown. Now, that does not mean that the online delivery or distance learning delivery of courses is going to stop. And in fact, if you read the executive order, um, Governor Whitmer, Governor Whitmer said that people delivering distance learning were considered essential. That doesn't mean I'm going to stop, you know, delivering classes from my basement. It just means that if I needed to, I could go into the office and I could work in the office to deliver courses. So, with that said, I want you to keep yourselves safe. I want you to keep yourselves healthy. I want you to keep yourself away from everyone else as much as possible. And I want you to connect with people like we are right now, video. Now, this is asynchronous. Actually, I'm recording this Monday night at about 6:10 p.m. You won't see this probably until tomorrow, Tuesday. But keeping that connection, just Zooming with your family, Zooming with your friends, Skype, Discord, whatever it is you need to do, please keep yourself engaged, keep yourself connected. It's the only way we're going to get through this, and we actually don't want to lose those connections. We will get to the other side of this. At least I'm hoping we all will. I've read that there are now 2 confirmed cases in Chippewa County. According to social media, which is not always the best source, the first case was an inmate at Kinross Correctional Facility. That person has been transferred down to Petoskey and is in the hospital in Petoskey. What this means, though, given that this was an inmate, was that the virus was brought in by somebody else. It was brought into Kinross Correctional Facility by someone else, which means it's already here. So, with that said, I'm going to drop video and we're going to continue on with our lecture. So as I mute my video, I'm going to share the PowerPoint slides that we have. Let's see, where did my PowerPoint slides go to? Show all windows. PowerPoint, there we go. So this is about where we left off yesterday. In fact, I think we were simply 1 slide above this, where we had actually produced main and had it run successfully, essentially duplicating program 5, which is due tonight. Program 5 is a stack program. And so we re-implemented that stack as a class. And we've got to ask ourselves, so what did this accomplish for us? Well, what was accomplished is that we now have an abstract data type, a stack, and the functions that manipulate it, that is push, pop, isEmpty, print stack, and they're all now in the same container, and they cannot be used by anyone except through an object of the container's type. So in our example program that I wrote yesterday, I called this thing myStick. So MY capital S TK for myStack. Now I can use myStack dot push, myStack dot pop, myStack dot isEmpty, myStack dot print stack, and those will all work. And we showed that. So just as a reminder, I'm going to drop the PowerPoint bring up my code screen, if I can find it. I think it's this one. Yes, it's that one. Awesome. Okay, and here's what our program looked like yesterday. This was ex6.cpp. It was created in the video lecture, and you should take a look at it. You should pay close attention to it, to what it's doing and how it works. So you can see in here, for instance, right up here, I've got a MyStack push, okay? So we read in the string, okay? And then I run a for loop for I equals 0, I less than the string length of in string, I plus plus, and then I push each of the in string sub i's, those are the characters, onto the stack. I don't have access to head. Head is private data. It's a private data member inside of the stack object or the stack class. And so my stack up here is of type stack. Okay, we push all those characters on, and then I print the stack. And then I drop into a while loop, and I'm using this not my stack is empty. Remember, my stack is empty simply gives us a true or a false. If it's not empty, so not my stack dot is empty, as long as it's not empty, I'm going to pop the stack and print out what gets popped. So what's going to happen here is that each character will get popped out of that stack and get output all on the same line. And then when I'm done, I'll have an ENDL, and then we'll return 0 because presumably everything ran correctly. Now, I've already copied this over to today's lecture, so I've renamed it ex7.cpp. Okay, and so if I run that now, it's going to ask me what the message is in the selfie. Hopefully I spelled that right. Yes, I did. Awesome. Okay, so print stack doesn't alter the stack. It just prints it out from top to bottom. And then the while loop pops each letter. And so each letter gets printed out on that single line with an ENDL right here at the end of the line. So what's going on here then is the while loop runs the first time through and pops S, because S is the top of the stack. The stack pointer moves down and is now pointing at U, and then U gets printed out. The head moves down in the pop to P, and then pop gets called again. The P gets returned, and the pointer is moved down again. Then the E, then the R, then the I, then the O, then the R. And when we hit here, when we get back the R, the stack pointer, the head, is null. So the stack is empty. And then we get the ENDL. So I'm going to drop that share. I'm going to go back to sharing the PowerPoint slides. Okay. And so now we're going to take the next step. That is, a class that implements an abstract data type should be separate from the class that contains the application data. This is information hiding. I talked about that a couple of lectures ago. You want to hide the abstract data types construction from the programmer that's choosing to use your abstract data type. So think of these two actors, or these two, entities. One is the programmer of the abstract data type, the ADT. And they're developing this abstract data type, but it is generic. It can be used for for anything. And so let's call that the programmer for the ADT, the Balrog. Now you've got the programmer who's using the stack in an application program. And we don't care what that application program is if we're the Balrog. We just don't care. We're implementing our stack. That's all we need to know. The application programmer is using our stack, but they shouldn't know how the internals are working. That is, the Balrog hides the information from the application programmer because, quite frankly, we don't trust the application programmer. Why? Because the application programmer is Gandalf. Gandalf is being held at arm's length from the Balrog's internal workings of his stack. Gandalf is using the stack for his own application program, but that application data shouldn't be available to the Balrog. We don't want Gandalf's staff to be accessible by the Balrog, and so Gandalf keeps his information hidden. Now, whether that anecdote works for you or not, I have no idea. But given that you're going to have lots of time during this lockdown and the continuing pandemic, maybe you should read The Lord of the Rings. Or at least watch it. Okay, so we're going to pull that application data out of the class for stack, and we're going to create a new class, which is just the application data. If you remember, the only application data in here is a single character. So we're going to create a class, a whole class, constructor, destructor, accessor, mutator, everything we need for a single character. And then later, what we'll do is we'll add to that, and we'll see that by adding to that, we actually can change what the stack is storing without changing any of the stack code whatsoever. So we're going to have a class that implements an ADT that is separate from the class that implements the application data. We will now have 3 .cpp files. We're going to have ex7.cpp, stack.cpp, and appdata.cpp. These will be compiled together to form one executable. Then we're going to have 2 .h files. Each class needs a specification, and so we're going to have a stack.h and a appdata.h. Okay. So for this next example, appdata will just be a single character. Notice how no application data is now specified in the stack class. We're going to tear that out of there. And we only have a generic app data type. So let's take a look at how that works. Again, I'm programming on the fly here, speaking as I go, so you can get some insight into the development process. Okay. Now I'm going to share back my screen where I'm doing my development. Okay, let's take a look in here. So we've got ex7.cpp, sensor.h. I don't know why sensor.h is in there. Bad copy. Stack.cpp and stack.h. So now I'm going to create a new file called appdata.h. Okay. This is going to be our application data. This is going to need to include IO stream. We're going to have a using namespace standard. And then we're going to have that, that preprocessor command, if not defined, if ndef, and app data. And in fact, I'm going to capitalize all that. okay? Just like we did with the stack. So here, let me jump out of this for a second. Go back into that stack.h, okay? Ooh, I didn't if ndef this. Huh, huh, huh. That's a mistake on my part. So I'm gonna, well, it worked. Huh. Well, this has me befuddled. I'm gonna go back and clean this up and put in the if ndef stack, and then pound define stack, and then down at the bottom, pound ndif. You know, the compiler is probably too smart for me now, and they've just decided that when you include multiple times, it's going to fix it for you. Wouldn't surprise me. It actually wouldn't be that hard to do in the compiler, but I'm still going to use the if ndef. Okay, so in here, same thing. If app data is not defined, then the first thing I'm going to do is define it. And then all of my code for the class will go in here. And then down at the bottom, I'm going to have ndif. So what's our class going to be called? It's going to be called capital A, PP, capital D, ATA. Class app data. Oh, there's that automatic Vim indenting for C. So I'm going to set no C indent in Vim. Okay. And now 1, 2, 3, 4 spaces over. I'm going to need a constructor. The constructor is named the same as the class. I am going to need a destructor. And that destructor is tilde, and then the same name as the class. Okay? Then I'm going to need, oh, wait, I need to make sure that those are in public, don't I? Public, okay. And then I'm just going to tab those over, 8 space tabs. So notice that my tab character here is 8. That's why I keep saying, if you're not using 8 space tabs, don't use tabs. Okay, so next line down, I'm going to need a getter and a setter, and those are going to have to be for the character, okay? So the character is the only piece of private data I have inside of here. And so I'm going to have a setter, void set, well, I don't know what to call this. My char? I probably should. No, I guess that's good enough. And this is going to take a single character as a parameter. And I'm going to call that the char. Okay. I'm also going to have a char type function. So the function is going to return a char. And that one's going to be get my char. And that's not going to take any parameter. And now I'm looking at this and I'm like, should I call this my char? I'm going to change it to my, yeah, I'm going to leave it as char. That's good enough. And now I need something to output this. And the problem is that this, this whole idea of output from inside of a class is kind of clunky. you know, I can see out things from inside of here, but what if I wanted to output the data from the class to a file? It turns out that what we really should do here is overload the stream insertion operator and eventually the stream extraction operator. For right now, I'm not going to do that. And the reason is I'm just going to keep this to the simple idea that we're taking that application data out of our stack definition and our stack code, and we're going to put it into its own separate class. And then I'm going to spend probably tomorrow's lecture looking at how that overloading of the operator works. Okay, so you should be reading in the book, and you should definitely be reading the operator overloading sections that I referred to in the PowerPoints a couple of PowerPoints ago. Okay, so for now, I'm just going to be print. Quite frankly, that's it. I'm just going to call it print. Print, what type should print be? Well, it should be a void. Okay, that's probably the best we can do. I'm going to go down, make a private section. And inside here is a single character called my char. Okay. Then I close off the class and I semicolon it. There we go. Now, that's pretty simple. And these application data classes, these things that physically hold data, are going to be rather simple. There's going to be a getter and a setter for each piece of private data. And eventually there's going to be a stream insertion, stream extraction operator overload, and an assignment operator overload. We're not doing those overloads yet, but you need to read ahead. You need to understand that operator overloading is one of the critical pieces of object-oriented programming. It's the thing that sort of makes things work nice and clean and easy, okay? So with all that said, what I'm going to do right now is I'm going to highlight this stuff. Oh, maybe not. I know this doesn't work. Okay, never mind. I'm going to get out of this file. Okay. I'm going to just type out the file, and I'm going to highlight that stuff. Now that highlighting in Unix simply means I've already copied it to the copy and paste buffer. So when I go into app data.cpp, that is creating this new app data, I'm going to have pound include IO stream. I'm going to have, remember, this is the critical part, pound include the local file appdata.h. Okay. And then using namespace standard. And now I need all of those member functions. Since I've got them in my copy and paste buffer, I'll paste them in. Okay. I'll get rid of the indentation like that. And now remember, you've got to be careful about your scoping operators. So this is app data scoped. Okay. Let's get rid of all these semicolons at the end of these lines too, because that's going to cause us problems if we don't. And in fact, I was helping a student during office hours today. And it took us 20 minutes to find a stray semicolon that was causing problems in his code. Watch your semicolons, okay? So now I've created this set no C indent, whoops, escape. There we go. Set no C indent. There we go. Get rid of that C indent. Quite often when I'm writing code, I put in the matching braces and then go back and write the code in between them. It just makes sure that I've got my braces all matched. So what needs to happen here? Not much. I'm going to set my char equal to, I don't know what. I'm just going to use a single character or a single quote because this is a single character. If I use the double quote, it would interpret this as a literal string, and you cannot dump a literal string into a single character. So in this case, I must use the single quote for a single character. Quite frankly, I'm just going to set it equal to the null character. That seems like a logical thing for me to do at this point. You could choose maybe a space if you wanted to. You could choose whatever you wanted to. To me, to my view of the world and the view of programming, the null character seems like the right thing here. Again, I need that scoping operator, and I need to set up the proper scope. So this is set up in app data. I'm going to put in some blank lines too. For those of you who are not using what we call white space in your programs, that is blank lines, you really need to start doing blank lines, okay? Break up your code into blocks that are doing the same thing or doing a certain task, and that way each block sort of is set off by blank lines. So here, there we go. My destructor is done. Why is there nothing in the destructor? Well, because the private data in the class app data has no dynamically allocated memory. There's nothing to get rid of, and so therefore, there's nothing to do. Now I could set my char back to the null character, let's say. But that isn't required. That's just being really cautious, but it seems more than cautious. Paranoid? I'll try paranoid. That seems really paranoid. Ooh, I don't want anybody to reallocate this memory and see the character that I had stored there. Now, if this were something like patients' medical records or students' grades, I definitely would be zeroing all that stuff out in the destructor. That is, make sure that the memory doesn't leave, little hidden footprints. But for a single character, who cares? I'm just going to continue on. So set my char. This is my mutator, my setter. And that's just simply going to say my char is equal to the char. That is the thing I passed in as the parameter to the setter. So right up here, I'm going to pass in data, a single character. Could be a literal character, could be a character I read from the keyboard. It could be a character that's in the middle of a string. But I'm going to pass it in, and we just copy it from the parameter into the private data, my char. Get my char essentially does the opposite. It is going to return my char. Now, Is there any data checking or anything we have to worry about up here? That is range checking or anything like that. Well, since this parameter is a char and this private data is also a char, they're compatible. And since we aren't restricting, we don't know anything about the application program now. Oh, wait, we are inside the application. We don't know anything about the stack right now. But the application program doesn't have any sort of restrictions on what that character might be. And so we're not going to do any error checking inside of here or range checking. Okay. So back down to here, my accessor is just going to return my char. And then my print is going to be really simple. It's simply going to be cout my char, and that's it. So if somebody's using the print function out in the real world, they're responsible for formatting. They're responsible for end lines. They're responsible for whatever they want to do. We're just going to output a character to the screen for them, and that's it. And by George, I think that's all of the code that goes into app data. We are not done yet, not by a good ways. Okay, so now I've got appdata.cpp, I've got appdata.h, but now I have to go back and change my stack class, because remember that character was embedded down in there. So right here in the struct, you see char data. What I'm going to do now is get rid of that knowledge of the application. The stack shouldn't have any knowledge of the application, and so it should just say app data. If we change app data, then this will automatically change what is being held in here. The other thing I need to do is I need to include that as well. So if I go up here, I'm now going to include I'm going to include appdata.h. Okay. So as long as appdata.h exists, as long as there's a class being supplied for the application data, we can compile and run this code and we'll be fine. Okay. Now, one last thing. Right here, you notice that this is a char. Again, we're going to change that to app data. And you'll notice right here, this is a char. And that should be app data. Okay. Now we need to make those changes in the implementation as well. So I'm going to go into the implementation file, and this is going to be a little bit more work. Okay. So I've got the constructor, the destructor. I've got the push right here, changes this to app data. Okay. So right here, so I'm going to highlight this. Whoop. Right here, we are setting app head arrow data, which is app of type app data, equal to the data, which is of type app data. Right now, because I haven't overloaded that assignment operator, I am assuming that those data types will be compatible and that the assignment operator will exist for that data type. I know it will because I know they're actually just characters, okay? But that doesn't mean that the compiler will know that. And so we'll have to pay attention when we compile. This might be a problem. If it is, then we're going to jump into overloading that assignment operator quicker than I may have alluded to earlier in the lecture. Okay, so that's where we're at right there. I'm going to go down. Whoa, bad highlighting. I'm going to go here, change pops return value to app data. That means I also need app data here for the data. And now I can no longer return this -1 char, okay? I am going to return the data, just the data. Now I want you to pay close attention to what I say here. I have declared the data to be of type app data. When I do that, the constructor for app data runs. The constructor for app data sets the character to the end of string character, the \0. That \0 never gets overwritten in here. And so when I execute the return right there, it's going to return \0. This is the value that we really should be checking for if we're looking for an error. That is, trying to pop an empty stack. Now, if the stack is not empty, we're going to do our usual, the data equals head arrow data, head equals head arrow next, and then delete temp, and then return the data. The data is of type app data. And so here again is another new idea. And in fact, up here, we had the same problem. When we pass something into a function that's of type app data, when we pass something or we return something back out of the function that is of type app data, there is something that needs to exist called the copy constructor. We haven't seen a copy constructor yet, but we may have to. I'm expecting the compiler is going to bark at me huge amounts when I try to compile this. If it doesn't, then the compilers have gotten way too smart. But if it does, this is probably one of the things that we're going to have to fix. We may have to fix the assignment operator overload, and we probably will have to fix the copy constructor. And in both cases, the code for those two is virtually identical. Okay, so is empty doesn't need to change. Print stack does need to change. Because remember here, we were couting that data. So temp arrow data. We can't do that now. That is data that we don't have access to. Okay. Now we've got data, but it's of type app data. Huh. So how are we going to print that out? Now remember, app data has a print member function in it. Dot print. This is gonna, oof, ouch, that hurts. That actually is really weird. And I'm going to tell you a little bit about operator precedence when you're dealing with object and pointer operators. When we look at a mathematical equation, we read from left to right. Multiplication and division are done first, then addition and subtraction. Dot and arrow are pointer operators, okay? Object operators. They bind from right to left. So the dot is going to get done before the arrow. And so that might cause a problem here, okay? So I keep just piling up all of these potential problems. And until we compile, I can't tell you if it's actually going to work or not. Why? Well, because I haven't done this stuff in about a year, and I didn't pre-program this code. So all I've got is a compilation. Oh, wait. And now ex7.cpp needs to change as well. Not only do I include stack.h up here, I'm going to have to include appdata.h. Okay. I've still got my stack. I'm still reading the in string. Remember, I'm the application programmer. I'm Gandalf right now. I know what's going on here. I don't know what's going on in the Balrog stack. Okay, so I've got a string. I know that my app data stores characters. And so here I'm going to push in string sub I. That's compatible with app data, I hope. I'm going to print stack. That should work. And I'm going to see out my pops. That should work. So let's try this. Notice the only thing I did in here was I included appdata.h. I know this is going to blow up. I can just feel it. Okay, I'm going to create the executable AX7, and that's going to come from compiling ex7.cpp, stack.cpp, and appdata.cpp. Boy, I don't even want to hit enter right now. I've been programming in C and C++. Well, I've been programming in C for 33 years. I've been programming in, well, 33 years this May. I've been programming in C++ for, let me think, I got to do the math, 14 years this coming August. And even I don't want to hit enter because I'm afraid of how many errors are going to come out of this. Whoa, look at that. That is a crap ton of errors. Okay. That just is wrong. Look at how many errors are there. So I'm going to grab the slider over here. I'm going to slide up, slide up, slide up. Do not get scared of this. Take your first error. My first error is right here, and fix it. Then recompile. Okay? My first error is that there is no matching function for call to stack push char ampersand. Okay? Which means my in string isn't going to work here. I really need a temporary variable of type app data, and I need to copy that in. I need to use my getters and setters, right? So, first error. Let's fix that. So I need something of type app data. And that's going to be, I'm going to call that temp data. Okay. Then down here where I'm pulling stuff out of the string. Okay. Set no C indent. Okay. I'm going to say temp data dot set my char with in string sub I. And then I need to pass in temp data. Okay. That's ugly. That is just a little bit of ugly code there coming from object-oriented programming. I'm using my setter right here, okay? And then down here, the same thing is going to have to happen in the while loop. I am going to need to say temp is equal to pop, okay? And then in here, instead of couting the result of pop, I'm going to cout, well, actually, I'm not even going to do that. I'm going to say temp dot print. And I'm not even going to cout it. Okay? Because I set that up to work, right? So temp dot print. Okay. Let's see if that fixed some of those errors. Okay. Again, this, oof. At some point, I must have hit the wheel on my mouse and pasted into my X term here. So now I'm going to compile this again. Wow, look at how many of those errors fixing those couple of lines of code did for me. That is amazing. Absolutely amazing. This is why I always say, fix the first error, none of the rest, fix the first error and recompile. So right now it's saying temp is not declared in this scope. And I know exactly what that is. I go back into here and remember I said temp data up here. So I've got temp data right there. But then down here, I've got temp. So if I make temp, so if I make this temp data equals pop and then temp data dot print, that should get rid of those errors. Recompile. Pop was not declared in this scope. Oh my. Let's go back. Remember that was my stack, my stk.pop, right? Okay. So I fixed that first error. And now I've got my char equals the char. My char was not declared in this scope. So this is coming out of appdata.cpp, but the problem, well, let's just type out appdata.h. My char is defined inside of appdata.h. inside of the class app data. So now I've got to go into appdata.cpp, and that's on line 17. So line 17. Oh, and I missed my scoping operator, right? So this is inside of the class appdata scoped. I forgot it on getchar as well. App data scope. And I forgot it on print as well. App data scoped. Here, that was too quick for you. I'm going to bring that back up and let you see that for a second. We are now just over 50 minutes of lecture, but I'm going to continue on until I get this running, just simply because I think it's important in one sitting to do all of this, get this running, and then break for today. So let's get out of there. Let's recompile. Oh boy, is it going to work? What is the message in the selfie? Yes, it works. Oh my God, that was a lot of code for me to write, a lot of niggling code to do. A lot of the things that I thought were going to break, like the stream or the copy constructor and the assignment operator overload, didn't break because the type of app data is so simple. There's only one piece of private data. And my goodness, it all worked. So I'm going to drop the share on that. I'm going to go back to my PowerPoint slides. Okay. It works. Oh my God. Now completed. What we'll do tomorrow is we'll change app data to contain more stuff. We'll make a new main, and we'll have to read in that extra stuff. And then we have to recompile to make it all work seamlessly. To make. Evidently that's one word, according to PowerPoint. It doesn't even flag it. Wow. So now what we have is a generic stack that we can use for any kind of data. I supply the class app data, and the stack will store it. No problems. That was actually pretty awesome. So remember, keep yourself healthy, keep yourself safe, keep yourself away from idiots, basically. We're going to get through this. At least I'm pretty sure we're all going to get through this. And I want to see you guys on the other side. And that's it for today's lecture.